Hello and welcome back. In this lecture, I want to provide a demonstration for our previous challenge, which was understanding pass by reference, having a parameter inside of a function take a pointer. So let's create a new project. We'll call this one pointer pass by reference because that's what it's demonstrating. Basic stuff here, new project, console application, C. Pretty straightforward here. Let's just call this pointer underscore pass by reference. Again, demonstrating how we can use parameters inside of a function to pass data and how that data will then be modified outside of the function. So the first thing we're going to do is we're going to create our function declaration, our function prototype. This is always nice to do so that you can call it anywhere in your program. We're just going to call it square. Main thing in this function declaration is it's going to take a pointer. So it's just going to take an int pointer, so we're just going to say int star, and then you can give it whatever name you want. And you end it with a semicolon. In our main function, first we're going to do is we're just going to create a regular integer variable. And we'll just say int num, and we'll just say hard-code it to 9. And what we're going to do is we're going to call our square function. Our square function is not going to return any data. It's going to be void. We have to pass it an address now, though, because our square function on line 4 is taking a pointer. So we can't pass in num. We would have to actually pass in the address of num. Right? And then we would end it with a semicolon. So we call the function using the function name and then passing the address of the variable. Because the variable here in line 8 is not a pointer. Then we can just basically print out the value of num. And again, what you'll notice here is because we're passing in the address, if we change the data in the function itself for that variable, it's going to change outside of it. So here we're just going to say the square of the given number is, and it's just say %d. We'll add a line feed, and we're just going to print out num. And num is not going to be 9, I'll tell you that much. And then we'll just return 0 for our regular functions. Now we have to actually implement the function, define it. To define it, I'm just going to say void square. We know it takes an integer pointer, so I'm going to say int star x. And now we want to just multiply it by itself, but we want to make sure that we don't change the address, right? So what we could do here is we could make this a constant, but you'd want to put the constant after the data type because we don't want to change the address of what x is, the value of what x is, or the address of what it's pointing to. So we could say int constant. If we didn't want to change the value of x, we'd say constant int, but we do want to change the value of x. We're going to square it by itself. So to square it by itself, first off, what we want to change is the ultimate value of x. So we have to use the indirection operator. We have to dereference it with the asterisk. And then we're just going to say equals. We don't want to do x times x because that's just going to multiply the addresses, right? X is a pointer. We don't want to just get the value of x. We want to get the value of what x is pointing to. So again, we have to dereference it. And then we're going to multiply it by itself. We're going to dereference it twice. It might be a good idea to put this in parentheses just so it's very easily understood what's going on here. You're dereferencing the pointer, getting the value of it, and then multiplying by its value. And then you just add the semicolon. And that's it. That's all you have to do. So when we run this program, it's going to print out 81. It's going to print out the value of num. Num is going to change because we're passing the address there. We're not able to actually change, though, the pointer's value. So we have the constant after the type. So here we say build, and it looks like we didn't change the declaration. I forgot to put the constant. And now we just want to make sure that everything else is correct. I did make a little mistake. If you want to have the pointer be constant, you have to put it after the asterisk. So int star, that means int star constant means that you can't change the value of x, which is the address of num. Right? If we put const before the int or after the int but before the asterisk, it means that you can't change the value of what the pointer is pointing to. So now when we run this, we should see as output 81. And again, what this tells us is, which we do, what this tells us is that we modified the data. This variable, this local variable num was modified inside the function and its value changed. That's not normal. We have not learned that concept up until now. That's pass by reference. But in C, what's happening is you're passing in a copy of the address. And that's why it's really redundant. We don't even need the constant, because even if we were to change the pointer's value, it's a copy of the pointer's value. So you don't really need to do that. Now, if we didn't want to use an existing number, we could create a pointer. We just have to allocate memory for it. So what we would have to do here is we could create an int star num. But what we'd have to do is first we'd have to cast the malloc, because malloc comes back with a void pointer. But we can allocate memory dynamically. And in here we'd have to say, really just because we're creating one integer, we could just say the size of int. And that would allocate memory for us. And then all we'd have to do is pass into square num. And then when we build this, it would do the same thing, but now we're actually, we don't have a value for num either. So it wouldn't actually know what to compute. So you'd have to actually assign to the value of num, we'll say here 4. You dereference it. And then now when you build it and run it, you should get 16. Now the only thing here is we want to print out the value, so we want to say num. And then when we run it, we should see 16. And it's really just the same type of behavior. And we see 16. The only thing difference here was we were allocating memory for what the pointer is pointing to, as opposed to just pointing to an existing memory location with ampersand. Again, important things to note here. This number is changing outside of the function. This is passed by reference. Understand where we're using the dereference operator, the indirection operator, to get the value of what the pointer is pointing to. Okay. Understand that if the function takes a pointer and we have a pointer, we can just send in the name. If it's not taking a pointer and it's actually a value, then we have to dereference it. And this is just like the scanf. So here we'd have to say the ampersand, and then also when we print it out, we wouldn't have to dereference anything because it's not a pointer. And then that would be the same thing here. And then understand const too. Const before the int star is saying that the value that the pointer is pointing to cannot change. The const after the int star is saying that the address of the pointer can't change, the pointer's value. Hope this was helpful. Again, play around with this, change some syntax, mess around like I did. It will help you learn a lot. Thank you.